All right, let's look at some review and preview problems starting with 623. For each pair of triangles below, decide if the pair is similar, congruent, or neither. Justify your conclusion with a flowchart or the reasons why the triangles cannot be similar or congruent. Assume that the diagrams are not drawn to scale. Redraw and label the diagrams as needed. Okay, so let's just look at A here. Things I notice, these two angles match. Obviously 140 and 21 do not match. So let's use the triangle sum theorem to figure out what this third angle in the first triangle is. So 180 minus 140 minus 18 is going to be 22. So this angle here is 22 degrees. So that does not match this angle here. It's very close, but doesn't match. So we'd say not similar because the angles have different measures. Okay, let's look at this second set here. And I'm going to zoom in a little bit to make this bigger. Okay, so things I notice, information they give us are that these two angles match. And they also tell us that the two lines are parallel to each other. So I notice that this is a transversal across two parallel lines. So this angle and this angle are alternate interior angles, and because the lines are parallel, we know that they are congruent. So if we have two sets of angles that match, we have enough to show by angle-angle similarity that the two triangles are similar. So let's see, the question asks us to justify our conclusion with a flowchart. This is going to be a little bit tricky. I'm just going to make life easy. I'm going to label these vertices A, B, C, and I'm going to say this is D and that's E. Okay, so I'm going to say the measure of angle A equals the measure of angle E, and the measure of angle B equals the measure of angle, let's see, BCE, to be very specific. And from that, we can conclude that triangle ABC is similar to triangle. Okay, so A corresponds to vertex E, B corresponds to C, and C corresponds to D. Oh, that's a little bit tricky. And we know that by angle-angle similarity. Now, I guess the last question would be, are these congruent? And we can see that this side, which corresponds to this side, have different lengths, so they are not congruent. All right, problem 624. Use what you know about the slopes of parallel and perpendicular lines to find the equation of each line described below. All right, so A, find the equation of a line that goes through point 2, -3, and is perpendicular to the line that they give us. Okay, so the line that they give us, the slope is -2/5. We don't care about this +6 at all. I'm just going to cross it out so it doesn't confuse us. We know that in part A, our line is going to have the form y equals. Now, what is the slope of a line perpendicular to a different line? We make two changes. We flip the fraction and we change the sign. So our original slope was -2/5. Our new slope is +5/2 x plus some y-intercept. And the way we're going to find the y-intercept is we're going to plug that point in for our y and x values. So -3 equals 5/2 times 2 plus b. Okay, and I can put this in my calculator, or I can notice that these twos are going to make a giant 1. So we get -3 equals 5 plus b. I'll subtract the 5. I find that b equals -8, and I put it all together to find that my equation is y equals 5/2 x minus 8. Okay, let's look at part B. We want an equation of a line that is parallel to this line and goes through this point. All right, so we need to first find the slope of our original line, but it's not in a form where it's easy to see. We need to do a little bit of work and solve for that y. So I'm going to add 3x to both sides and divide all of my terms by 2 to find my original line has this equation. The slope of my original line is 3/2. My line is parallel to that, so it's going to have the same slope. Remember, parallel lines have the same slope. So my new line is going to have this form. And just like we did before, we need to solve for our b by plugging that point in. So my y is 7, x is 4. Let's see, 3/2 times 4 is going to be 6. And I get that b equals 1. So my final equation is y equals 3/2 x plus 1. Okay, problem 25. In the diagram at right, the triangle ABC is similar to triangle ADE. Okay. Draw each triangle separately on your paper and include all measurements. Okay, so let's draw our two triangles. Here's ABC, and here is ADE. This is 14, this is 10. Let's see, what is AD here? Well, it's these two things together, so it's 8 plus 14, which is 22. And that's all the measurements that we have. And they want us to find the length of side DE here. Okay, so 14 is corresponds to 22. I'm going to call this side X, and 10 is going to correspond to that. So we make our ratios. 14 over 22 equals 10 over X. And now we'll cross multiply. 14x equals 220 divided by 14. And 220 divided by 14 is 15.7. Problem 26. Examine the two triangles at right. Are the triangles congruent? Justify our conclusion. If they are congruent, complete the congruent statement. Okay, so let's just take a look at these two triangles, zoom in a little bit. What do we know? We know that these two angles match. And we know that these two sides are the same length. And let's see, what is the missing angle here? 70 plus 60 is 130. So this missing angle is 50. Or here, 70 plus 50 is 120, so this missing angle is 60. Okay, so these two angles match. And also we know that these two angles match. All right, so I am pretty convinced that these are similar. And do we even know that they're congruent? Well, because these two sides, DE and JL, are congruent to each other, we can say that they are congruent. So we can say similar, similar by angle, congruent because DE is the same length as JL. This shows what those signs are. And triangle DEF, so let's see, I'm going to write it here. Triangle DEF is congruent to, remember there's a congruent symbol, triangle, let's see, L corresponds to D, J corresponds to E, and K corresponds to F. All right, what series of transformations are needed to change DEF to LJK? Let's see, could we just do a rotation? If we rotated E to fit on top of J, F and L would be kind of on top of each other, which don't correspond. So we are definitely going to need a reflection and probably then a rotation, maybe a translation, depending on where we rotate or reflect from. Okay, if DE equals 4 units, so if we know that this equals 4, what is KL? So if DE equals 4, we know that this also equals 4, and we want to know this length. Okay, well here we have a triangle that is not a right triangle. We know 3 angles, but we don't, and we want to find a side. So I'm going to rewrite our triangle there just to make it less crowded. Okay, this is 70, this is 60, this is 50. We know this side is 4, and we want to know this side. So I'm either going to have to use the law of sines or law of cosines. So let's just think, here I have an angle and the side across from it. And here I have an angle and a side across from it. So I can use the law of sines. So I could say sine of 70 over x equals the sine of 60 over 4. Okay, what is sine of 70? Let's see. We type that into our computer, or into our calculator. And we get 0.774 over x, and sine of 60. We type that into our calculator. And we get 0.866 over 4. Okay, now we cross multiply. I get 0.866x equals 4 times 0.774. And I undo the multiplying by dividing. Oh, and you know what? I am realizing I had my calculator in the wrong mode. This isn't 0.774. Sorry. Sine of 70 is 0.9396. So to fix that, it's a good reason to show your work so that when you make a mistake, you can know how to fix it. So that times 4 divided by the sine of 60. I get that x equals 4.34. Great. And problem 27. If b plus 2a equals c, and 2a plus b equals 10, then what is c? Okay, well, I notice b plus 2a and b plus 2a just in a different order. If I know that 2a plus b equals 10, I can substitute that in here. I can say, well, b plus 2a is 10, and that equals c. Okay? And I know that because I'm using substitution.